Good day, ladies and gentlemen. This is Sarel van Grennen, aka Mr. VG, and we are now getting to the really important part of this chapter, where we are looking at practicing the exponential laws. Now, in this video, we are specifically going to practice the law 1 and 2 of exponents. We are going to do this by looking at these 5 examples. Now, these 5 examples are basics, and they may not get this in the exam, although maybe in question 4 or 5 you might get in the exam. So you go try it yourself first before you look at the rest of this video. So when we start with this, a very important thing to remember is that the powers need exponents. So in the first one, I put the 1 by the a, just so that I don't forget that there actually is an exponent. I'm multiplying, look at this, I am multiplying the same exponents, or the same bases. Therefore, I can apply law 1. And what does law 1 say? I can simply add the exponents. So I go from 3 bases to 1. A to the power of 2 plus 3 plus 1, which then is a to the power of 6. Let's have a look at question 2. Now, question 2 and the rest, I'm first of all just going to write all the 1s where there should be 1s, just so that I don't get stuck there every time. Question 2, I am dividing the same bases. I'm dividing bases with the same a. So can I apply law 2? Yes. Law 2 says I now subtract the exponent. Top exponent minus bottom exponent, which leaves me with a to the power of 4. If you wanted to do this using your definition, you can do it as well. Write out your 5 a's at the top, write out your 1a at the bottom, and then one of the pairs of a's will divide away, leaving me with 4 a's. Okay? That is as simple and as easy as that. Now we start getting to where life is interesting. Question 3. I'm sitting with 2x raised to the 2 times by 3 raised to the 2x raised to the 1. So what I would like to do is actually rearrange this so I put all my numbers together and all my x's together. So I'm just shuffling this all around. I'm not doing rocket science. I am allowed to do that because remember, there's an invisible multiplication between the numbers and your variables. This means that, ladies and gentlemen, I can actually look at the numbers and the x's separate from one another. Can I apply law 1 with the numbers? No, because the bases are not the same. So I'm just going to handle this using normal definition. So I'm going to say this is 2 times by 9, because that's what 3 squared is equal to. Remember, that means 3 times by itself. And if I look at that, the back x's, I can apply law 1 because there is a multiplication and the bases are the same. So therefore, I'm sitting with 2 times 9, which is 18, x to the power of 3. Simple and straightforward. Now let's go and try question 4. It's the same as question 3, but instead of multiplication, now I am dividing those numbers. So let's do them separately. The numbers, the k's, and the r's. So if I look at that, I'm just going to split them up like that so that life becomes simpler for us when we're working with this. First of all, I can divide the 21 and the 7 by 7, which leads me to 3 over 1. Can I apply law 1 or law 2, I mean with the k's? Yes, I can, because it's division as well as same basis. So I can say this is k to the power of 2 minus 1. And what about the r's? I can repeat this process. R to the 8 minus 4. This gives me a final answer of 3k times r to the power of 4. I hope you get this, ladies and gentlemen. Step by step by step. You do the numbers, you do the k's, then you do the r's. And last but not least, a typical exam type question, where we now have multiplications and divisions all in one sum. So before we freak out, let's start at the top. So I'm going to again shuffle this around. I'm going to handle the 3 and the 6 separate from the x squared and the x to the power of 1. The denominator I leave as is. So let's multiply the 3 and the 6 first of all. Okay? I'm just copying over the denominator so long. 3 times 6 is 18. And can I apply the first law at the x squared and the x? Yes, I can. It's multiplication and it's the same basis. So I'm going to add the exponent. So I am effectively sitting there at the top in the numerator with 18 x to the power of 3. Now that I now have to look at the second law. So I'm first of all going to divide both numerator and denominator by 9, and that gives me 2 over 3. Then I'm going to apply the second law, which says I take the top exponent and I subtract the bottom exponent from it. And this leaves me with 2 over 3 x to the power of 1. Do I have to write the 1 there? No, I don't. I don't. But if it makes you happy, you are most welcome. Ladies and gents, this is a bit more of a tricky one, but not that tricky if you just take it step by step by step. So this is Mr. VG signing out. Have a beautiful and amazing rest of your day. Keep well. Cheers.